Hi guys, how you doing? And it's Jalaj Aura here again, back with another video from BioGem at GCSE Chem. And I need to say a couple of things before we kind of start the video. First of all, I want to say happy Raksha Bandhan to anyone, to all kind of everyone celebrating, and to basically all of you, like even if you don't celebrate it, it's a really good festival. It's an Indian festival basically where sisters tie their brothers Rakis, and it's what we these kind of these thread kind of things. I'll show you my one. So it's basically a way of it's a festival in which sisters and brothers can kind of come together, unite, and it's a really good festival, and yeah, it's nice to have some really pretty things on the arm, on the wrist. It's a wrist, isn't it? I don't know, whatever. But yeah, it's a wrist. Pretty sure it's a wrist. It's just a way for sisters and brothers to come together again, unite, and I haven't seen my cousins for like 2 years because I haven't gone to India for like more than 2 years. So today I saw them, after more than 2 years on a Zoom meeting. So it was really good to see them after so long, and we had a really good day. So yeah, just happy Raksha Bandhan to anyone. Everyone basically. And I couldn't upload, I couldn't put the links to C3.2, C3.3 and yesterday, so I'll be making C3.4, and hopefully I can update all of them, put the links on my website by the end of today. But if I can't, definitely it'll be done by at least the end of this week, so it should be updated soon enough. Sorry I can't do it, every day on a daily basis. Sometimes I just don't get time to do it. But yeah, it should be done soon, hopefully. And today we're going to be doing C3.4, which is giant ionic structures. Another thing that, another section very much linked to ionic bonding. So it can, it's very much interlinked, these last three sections. So C3.4, C3.3, C3.2, they're all linked with each other. And before we move on to covalent bonding, which is C3.5, but yeah. So I think I've talked a lot, and I don't think I missed anything else. Other than today we're doing C3.4 Giant ionic structures, and by the way, if I haven't even shown you the book, have I? This is the GCSE Chemistry AQA Caboodle revision guide. So that's the book I'm using. Have I shown you properly? There you go. And yeah, also as you can probably see that I am in my room today making the video, because obviously my parents are downstairs, they're watching television, didn't want to disturb them. So and sorry if you can hear any background noises, I'm trying to keep that to a minimum, but yeah. I think that's about it. So I think let's begin. That's all I needed to say. So now let's begin. So obviously C3.4 Giant ionic structures. If you're following the student book, it's pages 42 to 43 that you want to be looking at in that big textbook. So yeah, ionic compounds have giant ionic structures in which many strong electrostatic forces operating in all directions hold the oppositely charged ions together. This means ionic compounds are solids at room temperature, and it takes a lot of energy to overcome the ionic bonds to melt the solids. Therefore, ionic compounds have high melting points and high boiling points. Now, I've read all that. Have I explained that? No, I haven't. But yes, will I explain that now? Yes, I will. So, so if that didn't make sense, don't worry. We went through this actually. I think we went through it briefly in the last section as well, but don't worry, I'm going to go through it again because it was a big paragraph, and I'm just going to explain, if you didn't understand what it was, what it was about. So basically, ionic compounds have giant structures in which many electrostatic forces operate in all directions, hold the oppositely charged ions together. Now I've read that again, but basically what that means, because we saw in the last video that ionic compounds have giant ionic structures, or giant ionic lattices, you can say, and basically they have there are many strong electrostatic forces of attraction between the oppositely charged ions that act in all directions, and these strong electrostatic forces of attraction actually hold the ions in place, hold the oppositely charged ions in place, like together. So this means that ionic compounds are, because all the oppositely charged ions are held together, in fixed positions, and a lattice structure. This means that ionic compounds are solids at room temperature, and that's what, hopefully that makes sense. And then obviously it just says that ionic compounds have high melting and boiling points because Obviously, a lot of energy is required to, overcome these strong electrostatic forces of attraction, or to overcome the ionic bonds and melt the solids. So hopefully that makes sense, because you have to overcome these strong electrostatic forces of attraction between the oppositely charged ions, and you have to kind of overcome the ionic bonds and melt the solids, and that really takes a lot of energy. So that's why ionic compounds have high melting and boiling points. So hopefully that makes sense. And then here's a question. Because obviously, just to kind of explain that further as well. Because if you kind of if you need more energy, you're increasing the temperature to melt the substance, right? When you're going from a solid to a liquid, you're increasing the temperature to melt the substance. Now, if you need a lot of energy, if you need a very, very high temperature, which is the case for high melting and boiling points, you need a very, very high temperature. That means you're going to have to supply a lot of energy to overcome these kind of strong ionic bonds and melt the solids. That's why, because you have to supply a huge, you have to increase the temperature by so much and apply a lot of energy. That's why they have high melting and boiling points to ionic compounds. So hopefully that's why ionic compounds have high melting and boiling points, that's why ionic compounds have high melting and boiling points, and hopefully that makes sense. So sorry if you can hear any noise in the background. It's my brother just speaking. But why do ionic solids have high melting points? Well, we've gone through that. There's a question, by the way, and the answer is simple. It's just that ionic compounds have giant structures, which have strong electrostatic forces of attraction, that hold the oppositely charged ions together, and and this means obviously that that means their solids are room temperature, and a lot of energy is required to actually overcome these strong ionic bonds and melt the solids, and therefore they have high melting and boiling points. Because because basically the higher the temperature you need it to be, the greater the kind of temperature increase you need, the more energy you're going to have to supply, and therefore the higher the melting and the boiling point will be. So let me just see the answer now, just to make sure I haven't missed anything out. And I don't think I have yet. So it says they have giant structures with strong electrostatic forces that hold the ions together. A lot of energy is needed to overcome these forces. Yeah, I said to overcome these kind of forces. Or you could say overcome the forces, or you could say overcome the ionic bonds, the strong ionic bonds, and and melt the solids. So that's basically what I said before. That's basically what I said. So now we're going on to the next part, which is, however, when an ionic compound melts, the ions are free to move. Now this allows them to carry electrical charge, so liquids can conduct electricity. So basically, when ionic compounds, when they melt, what happens is basically the ions, the oppositely charged ions, basically, because now it's in solution. Now the ionic compound is molten or dissolved in water. It could even be dissolved in water, or dissolved in solution. I'm pretty sure. You can say, was it molten or dissolved in water or dissolved in solution? I don't know. I'm pretty sure it's molten or dissolved in water, but it could be molten or dissolved in solution. So I'll check that, and I'll probably kind of in fact I'll check that, and then wait, why not? Why don't I check it now? 1 minute. I'll just make sure I'm not saying the wrong thing. So ionic compounds, so molten or dissolved. 1 minute. Dissolved in solution. One minute. Just taking the internet's just loading. It's just loading. I've just searched it up. Oh, here in the book, by the way, it's taking so long to load. But here, okay, yeah. So actually, let's just read on because I think it says in the book. However, when ionic compounds melt, when an ionic compound melts, the ions are free to move, and this allows them to carry electrical charge, so the liquids can conduct electricity. Hopefully, that makes sense. When you melt an ionic compound, the ions will now be free to move, and this would mean that the liquids can therefore, they can this allows them to carry charge, so then they can now carry charge, and therefore, the liquid can conduct electricity. So hopefully that makes sense. I'm really sorry about the noise, around me, but yeah. Some ionic solids dissolve in water because water molecules can split up the lattice. The ions are free to move in solution, and they can all conduct electricity. Yeah. Well, some solids dissolve. Oh, so wait, let me just read that again. Some ionic solids dissolve in water because water molecules can split up the lattice. The ions are free to move in solution, so they can also conduct electricity. So it's molten or dissolved in water. So when ionic compounds are molten or when they're dissolved in water, they can conduct electricity because they can, because they have ions which are free to move that can carry the electrical charge. So yeah, and the water molecules can actually split the ionic lattice up, because remember, the ionic lattice is solid. It's a giant solid ionic lattice which can be broken up when it dissolves in water. So that means that they, therefore, if the ionic compounds which are molten or dissolved in water can therefore conduct electricity. So hopefully that makes sense, because the ions are free to move and they can carry the charge. And here is here's a question: why can ionic substances conduct electricity when molten or dissolved in water? Well, we've just been through that. It's because they have ions which are free to move that can carry the charge, and therefore the liquid can conduct electricity. Basically, therefore the ionic compounds can conduct electricity. So that should be the answer, which I'll just check to confirm. But if I missed anything. But no, I don't think I have. The ions can move freely and can carry the charge. So I've just said that. And here's just a diagram of a 3D model of a giant ionic lattice. So you can see the positive ions and the negative ions, and they they kind of tightly packed together, kind of there in a fixed arrangement in a giant ionic lattice. So that's a solid ionic compound. So let's see. So here it just says in the labels that that strong electrostatic forces of attraction called ionic bonds. So these strong electrostatic forces of attraction are what we call ionic bonds. So they're called ionic bonds. So that's important to know. And here it just says 3D model of a giant ionic lattice. And then just to finish off with the key points. So are there any? Yeah, there are no keywords in this section. So, but just to finish off with the key points. So it takes a lot of energy to break the many strong ionic bonds operating in all directions that hold a giant ionic lattice together. So ionic compounds have high melting points. They are all solids at room temperature. So we've been through that. Ionic compounds are solids at room temperature, and we've also been through the fact that they have high melting points because they have giant structures. Giant ionic, or they have giant ionic structures or giant ionic lattices. You could also say with strong electrostatic forces of attraction that hold the oppositely charged ions together. And lots of energy is required to break these strong ionic bonds, or you could say overcome these strong forces of attraction. You could also say, therefore a lot of because a lot of energy is required to break it, to raise the temperature for the melting point. That means that ionic compounds have high melting points and also boiling points. But they're solids at room temperature, which is obviously very important. And the last point is that ionic compounds will conduct electricity when molten or dissolved in water. This is because their ions can become mobile and can carry charge through the liquid. So we've been through this as well. Ionic compounds will conduct electricity when they're molten or dissolved in water because they're the ions within them are free to move. They can carry the charge, and therefore the liquid they can carry the charge through the liquid, making the ionic compounds conduct electricity. And that's the end of this section, C3.4, giant ionic structures. And tomorrow we'll be going through C3.5, which is all about covalent bonding. And so that's the end of the section, guys. I'm just really sorry about the noise, in between. But I'll try and do better in my other videos for that. But hopefully this video was helpful for understanding, you know, C3.4 Giant ionic structures, I believe it's called. Yeah, and I haven't updated my website yet for these for the links to C3.2, C3.3, and C3.4. Hopefully, I can do them all by today. If not by the end of this week, I'll have, you know, the remaining of chapter 3 all on my website. But I think it will take more than a week to actually finish chapter 3 because it is quite a big chapter. But basically, you know, I'll try and upload. I'll try and put the links up as soon as possible. Make sure to share, like, and subscribe. Turn the notification bell on if you haven't already, so you're notified and updated when I upload new videos that you can watch. And yeah, until tomorrow, see you guys, and yeah, thank you very much.